Good morning, students. In today's module, we are going to discuss about the reactivity series of metals and two chemical properties of metals with dilute acids and with another metal salt. Let us see what is reactivity series of metals. The arrangement of metals in a vertical column in the order of decreasing reactivities is called reactivity series of metals. In reactivity series, the most reactive metal is placed at the top, whereas the least reactive metal is placed at the bottom. Though hydrogen is not a metal, it has been placed in the reactivity series of metals. It is due to the fact that metals can lose electron and become a positive ion. Hydrogen also loses electron and forms a positive ion. Potassium, the most reactive metal, is placed on the top of the reactivity series, and gold, the least reactive metal, placed at the bottom. The order of reactivity is potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, mercury, silver, and gold. Now, let us see how a metal reacts with dilute acid. Metals usually displace hydrogen from dilute acids. All the metals which are above hydrogen in the activity series displace hydrogen from the dilute acids. Reaction of metals with dilute HCl are exothermic. They evolve heat. Metals which are below hydrogen do not react with dilute acids. In general, we can write the equation as metal plus dilute acid gives metal salt plus hydrogen gas. The metal salt will be in the aqueous state, but we will not consider potassium and sodium metals as they react vigorously even with cold water. When calcium or magnesium are taken, they react with dilute HCl quite vigorously, and the rate of formation of bubbles of hydrogen gas is fast. The bubbles will be formed quite fast. The reactivity decreases in the order of aluminum, zinc, iron, lead. Copper does not react with dilute HCl as it is below hydrogen and is least reactive compared with hydrogen. The hydrogen gas evolved is passed through a soap solution taken in a trough. You can see in the diagram, you consider or you take soap solution in the trough of water, and the gas evolved is made to pass through the soap solution. Here, the purpose of taking soap solution is to see that the bubbles of hydrogen gas are formed. The gas, when passed through the soap solution, it does not dissolve in it. When it touches the surface of the soap solution, the bubbles of the hydrogen gas will be formed. Now, we will see whether a metal can react with nitric acid or not. HNO3. When a metal reacts with nitric acid, HNO3, then hydrogen gas is not evolved. The reaction does not take place. The reason is nitric acid is a strong oxidizing agent. So, the hydrogen gas formed in the reaction between a metal and dilute HNO3, the nitric acid will oxidize this hydrogen to water. When it is oxidizing hydrogen to water, it itself will be reduced to the oxides of nitrogen, to the different oxides of nitrogen. N2O, dinitrogen monoxide, NO, nitrogen monoxide, or NO2, nitrogen dioxide. But very dilute nitric acid reacts with magnesium and manganese metals to evolve hydrogen gas. This is because the dilute nitric acid is a weak oxidizing agent. But remember, you should take very dilute nitric acid. It is a weak oxidizing agent and is not able to oxidize hydrogen to water. But only magnesium and manganese metals can react with dilute nitric acid. Now let us see how we can write the chemical equations for a metal with dilute acids. When a metal reacts with dilute HCl, you will get the respective metal chloride in the aqueous state and hydrogen gas. For example, Zn plus dilute HCl gives ZnCl2 plus H2. ZnCl2 is zinc chloride. When a metal reacts with dilute sulfuric acid, we will have the respective metal sulfate and hydrogen gas. Metal plus dilute H2SO4 gives metal sulfate plus hydrogen. Zn plus H2SO4, we will have ZnSO4 plus H2. Now, let us see the chemical equations of magnesium and manganese with nitric acid. Magnesium Mg plus HNO3. We will have MgNO3 twice plus hydrogen. MgNO3 twice is known as magnesium nitrate. In a similar way, even manganese reacts with nitric acid to form manganese nitrate and hydrogen gas. Mn plus HNO3, we will have MnNO3 twice plus H2. Now, we are going to learn what is meant by aqua regia. Aqua regia is also known as royal water. It is a freshly prepared mixture of concentrated hydrochloric acid and concentrated nitric acid in the ratio of 3:1. Concentrated hydrochloric acid 3 parts and concentrated nitric acid 1 part. So it is 3:1, HCl is to HNO3. If you write concentrated nitric acid first, then you will have the ratio as 1:3. So it is 3 parts of HCl and 1 part of HNO3. This aqua regia is a highly corrosive fuming liquid. It can dissolve all metals, even gold and platinum can be dissolved in aqua regia. concentrated nitric acid or hydrochloric acid, when you consider them separately, they cannot dissolve gold, but aqua regia can dissolve gold. Now, let us consider a copper wire and an iron nail. Place the copper wire in a solution of iron sulfate, FeSO4. FeSO4 is green in color. Now, place the iron nail in a solution of copper sulfate, which is blue in color. We will observe that iron, which is placed in copper sulfate, will react with copper sulfate. It displaces the copper, the less reactive copper, from copper sulfate and forms FeSO4, iron sulfate and Cu. So you can have Fe plus CuSO4, FeSO4 plus Cu. The color of blue copper sulfate changes to light green of FeSO4. Reddish brown copper is deposited on the iron nail. But in the other test tube where you considered copper wire, it is less reactive than iron, so it does not react with FeSO4 and we will not observe any change. Now, the general equation for a metal reacting with a salt solution of another metal can be written as metal A plus salt solution of metal B. But here you should remember the equation to take place, the metal A should be more reactive than metal B. If metal A is less reactive, then the chemical reaction will not take place. Metal A plus salt solution of metal B. We will have salt solution of metal A plus metal B. Let us see the equation for this example. Already we have discussed in the activity. Fe plus CuSO4. We will have FeSO4 plus Cu. But Cu plus FeSO4. Here copper is less reactive than iron, so chemical reaction will not take place. Let us see one more example. Zinc plus copper sulfate, Zn plus CuSO4. We know that zinc is more reactive than copper, than Cu, and hence it displaces copper from copper sulfate. We will get a colorless solution of zinc sulfate and reddish brown copper. We can write the chemical equation as Zn plus CuSO4, ZnSO4 plus Cu. So far, we have discussed 4 chemical properties of metals. The first one with oxygen, with water, with a dilute acid, and with a salt solution of another metal. In the next module, we will learn how a metal reacts with a non-metal.